Okay, now we've used this Jupyter web app, or the Jupyter notebooks here, to learn something about calculation, something about pandas, and also introducing some plotting libraries. But now it's about time that we actually start to use this with industrial data. And let's go into here and stop our Jupyter notebook here, and we're gonna use VS Code from now on. VS Code together with the WSL. The reason why it's smart to get into WSL and stuff like that, it's because things simply work a lot better when it comes to using WSL for when you're gonna start to use CUDA cores and stuff like that. When you're gonna do proper machine learning, then it's then everything sort of is running from a WSL environment or from a Linux box running somewhere. Maybe it's a Linux box in the cloud, but it's mainly a Linux box. So it's a good habit to get straight into using WSL, and things mainly work here. I also set up this video on how you can actually set up your WSL environment previously, that I can link below in this video, where we set up Python and where we have different Python versions and stuff like that. You see here, I've selected 3.10.9 for this thing, and also pip installed install Poetry. That's already installed, and Poetry config virtual envs in project, set that to true, so that the venv is actually inside your directory. That's a good thing to remember. But yeah, let's now start to set up our Python environment. So here you see all our Jupyter notebooks, and let's now kick in and start up a new Poetry project, where you can actually have an isolated environment that we work on with the VS Code, and that the other people can maybe also easy take it to their own to use for their own analytics and build upon the things that you create. Because if you just run things on bare bones, your Jupyter notebooks on your global Python interpreter, that's not the best thing to do when you're supposed to share and do work with others. So we Poetry new, create a new Poetry project, call it Valve Diagnostics, because we're gonna look into some data science-ify some feedback data from the position of valves and how they behave, and do some analytics on that. And that's a really nice case that I love to show, because it's builds up a lot of intuition, and it's a beautiful way of getting into in playing with industrial data. So now we have created a directory called Valve Diagnostics, and let's cd into it, and from here we can open it up in VS Code by pressing code and dot. Now we're in VS Code. I guess we can open up a new terminal, and yeah, I think we might be able to start this. So this is a Poetry project. So let's just add the basics. So NumPy, pandas, and matplotlib. That's and you see now it's creating the VM for us, and it's opening up the VM and creating it inside our project directory. And for just quickness sake, let's open up a new file here and just call it main.py, and yeah, let's print something. Hello industrial data user, industrial data wrangler, because that's what we're gonna do. We're gonna wrangle some industrial data from industrial data repository called CDF. That's gonna be nice. Let's just see if we now we actually need to set our Python interpreters as well. So open up the command palette, so Control-Shift-P or whatever it is. Search for Python interpreter. Yeah, select it here. And now, oh, it has already recommended here. It has found it. So inside the venv and bin Python. But if it's not here, just enter interpreter path, and then we can find it. Now we are inside like this Valve Diagnostics directory here, but we go one step back and find the .venv here, .venv bin, and find the Python here. So now we've selected that as our Python interpreter. But if we just want to run this this Python file, you can go here, poetry, run, and now we're actually inside the virtual env that's been set up. And when we're inside the virtual env, so let's just run Python of, I need to get in the directory, and main.py. This is poetry. So hello, industrial data wrangler. That works. That's nice. So now actually the Python thing here works. So we can try to set up a notebook. Notebook.i Python notebook. Python notebook. But before I start this up, I think we're gonna need to install the IPython kernel. You could just select it there and it will find it and install it yourself, but if you want to maintain and keep everything inside our PyProject.toml file, where we actually add in all our dependencies, our dev dependencies and all these things. So we can poetry add IPython kernel. I'm just closing it if something happens, and now it's also put in IPython kernel here. So now when we open up the notebook here, we need to select the kernel here. We select the Python environment, and you see here the .venv inside our environment venv here is sort of chosen here. So we choose that. Import OS works. We can dir the OS. So now you see here that this actually works. And the things that we've learned from previously, and double tap there, and then it works. Print hello. Now it's this is actually working. So of course we do the things that we all know. Import numpy as np and import pandas as pd. That's a good place to start. And also we can just import from datetime, import datetime. These are all the things that we've learned about previously. Essential libraries for doing anything. But yeah, now we have a Python environment working up and running. It's isolated inside this virtual env that we have running inside our directory. So everything is closed into this environment. So this will be very easy to package into a container or something like that later, because it's all stored with the versions of everything that we use, and it's all scoped locally here. So that helps with the hygiene of the project. Okay, what is this CDF thing here? Here's the main page, cognite.com, of the data repository we're actually going to use. You even see behind here, these are heat exchangers and stuff like that. And we're going to work with equipment that's quite close to these heat exchangers that actually shown here. So that's quite nice. Into products and this Cognite Data Fusion here. So what Cognite Data Fusion is actually, it's a place where you can collect all your industrial data. Say your operational data, that's like data from historians, from OPC UA servers, from SCADA systems, time series data from SCADA systems, and maybe even equipment hierarchies from OT systems, MES, that's like manufacturing systems, where you have many, many CNC machines working in tandem and trying to set together a multi-part build, or you're operating some facility where you're trying to produce some chemicals or do some processes, or what we're gonna look into is an upstream oil and gas facility in the North Sea, where that gets oil and gas from a reservoir, and we're gonna get data from the first stage of the gas treatment of this data. You can also add in conventional IT data, so that's ERP data, that's might be work orders, like and control of work data. There's so many things on the ERP level that you can get data from. Also, you have simulation, 3D drawings from ET, from like engineering data. You have PNIDs. You have so many different diagrams and information, data sheets, and all these things. Even documents, can be anything from PDF, from Word documents. Anything that that's related to this facility. You can even have like robotic data sources. You can have autonomous robots going around and pushing data into this CDF data repository. And this takes in the data and collects it into something called resource types, and that's sort of the building blocks upon this Cognite Data Fusion. And those building blocks, those are abstractions that are fantastic to work with, because they're really, really close to reality, and that's sort of very beautiful. Because sometimes inside systems, maybe like ERP systems and stuff like that, the abstractions become too abstract, but you need abstractions that are closer to reality. I can see here, but we can just go to docs.cognite.com, straight into the developer. Gonna use some SDKs, but just quickly about the resource types. Here's an overview of the resource types: assets, time series, events, files, 3D models, sequences, labels, relationships, also raw, and there's also some geospace, and seismic resource types. There's some others as well that you might come across, but these are like the main: assets and time series and events and files. And sequences are the things we're gonna mainly work with. But right now we're mainly even gonna work with time series mainly. I can also look into some files and explaining some of the process. Sequences. This is actually basically a data frame or a spreadsheet of data where you continuously just add in row by row by row. So that's a nice way of using, if you have something that's something that feels like a data frame or an Excel spreadsheet. Sequences, it's really good to use if you just want to add another row. Time series, that's basically trends. So it's a collection of data points where you have time and a data point. Assets, that's like the main thing. It could be an equipment, it could be a pump, could be a skid with a lot of pumps, but all these assets might have more or can have time series. Say it's a pump, then you might have a time series that says how much outflow is from this pump, and what's the suction pressure, or what's the discharge pressure of this pump. Also files, you can have data sheets, maintenance things, how you're supposed to maintain this, the videos of how things work, images of how things look, and 3D models of this asset, and all this can be combined so you can see anything from anything. So it's quite the nice abstractions that's used inside CDF here. But yeah, and if you want or need to get like support or anything, then you have something called Cognite Hub you can use. And we're gonna use the public data CDF project, or the Open Industrial Data project, together with the Python SDK. So that's gonna be quite nice. We can even have even further look into time series. Here you see, here you see the raw response. If you actually just do a raw API query, but we're not going to do raw API queries into into CDF, we're gonna use the SDK that's gonna do this for us. So they will package up the JSON request and do maybe even use like the requests libraries from Python. That's really popular, and they will pass the request in, and we'll get the JSON response, and this JSON response will be actually packaged into a pandas data frame for us, so we can straightly go to work. But in raw, what the SDK does for us is to make it so that we don't have to handle with this JSON thingamabobs and these raw REST API requests. So yeah, Python SDK, get started. Pip install Cognite SDK. Okay, that's a good place to start. We're not gonna pip install, but we're gonna poetry add Cognite SDK. Gonna use version 6.4 or something. Yeah. Oh yeah, you see here requests. So even Python Cognite SDK also uses requests in the backend to handle these RESTful API requests that they're going to use in the backend. There's also flexible data requests like GraphQL that you can use, but we're going to focus on the simpler parts. How we authenticate using this? We need some credentials, and when we get these credentials, we pipe that into a client config. And this config you then put into a Cognite client, and then you get this REST API client or REST API SDK client that we're gonna use. So we're also gonna use OpenID Connect OIDC against an Azure Active Directory. It's actually the same Azure Active Directory that runs Cognite Hub. That's available to anyone in the entire world. So you can register with any email here and get access to this data. So authenticate with Azure Active Directory. Okay, when we want to authenticate, it installs the Microsoft Authentication Library. I think if we jump back, you see MSAL here. It also uses that in the backend. So to help us to make this more smooth. We need a couple of things. We need to know what cluster we're in. We are actually using the API, so api.cognitedata.com for the data we're going to look into. That's basically what cluster or what data center the CDF project is hosted. Tenant ID, and this is the Azure Active Directory tenant ID, and also client ID. That's the Azure Active Directory registry ID, and that's called the client ID. That's the thing we need, and we're gonna authenticate using interactive logon. So we're gonna like, oh yeah, now you need to log into Cognite Hub, and then you have access to this. You also see that here, the Azure Active Directory application should be like set up that you can use this redirection URL here. So that it can work. Okay, there's two other ways. It's either with device codes, that's for headless devices, and something called client secrets. Client secrets, that's when you have a bot or something running on a schedule that's not a human. Say that you have created a calculation that you want to be run every 30 minutes or something, or every second. You have a machine learning model that's inferencing and constantly pushing real-time data into something. Then you have to use client secrets to make this create like this virtual sensor or something that can work inside CDF. And then this client secrets you would use to get that. But we are going to use interactive logon with token refresh. Here's some code sample. Okay, this didn't work. Now we just go straight into single source truth into the GitHub. This is the GitHub for the Python SDK. And here we have SDK documentation, CDF API documentation, and also Cognite developer documentation. You can also see the pip install, how you get it, and some other things if you want to have an even more specific version of the Cognite SDK with the GeoPandas and stuff like that. But let's not go there yet. And here, I guess the CDF API work here, because there's the documentation is automatically generated every time someone pushes something into the master here. So let's just have a look into this SDK documentation. Here it works. And look into the credentials providers. But we wanted to use interactive logon. Here is if we're going to straight up use a token, because it needs a token and sets the token into the head of the request. But we're not going to use token. OAuth client credentials, that's with client secrets. That's when you have a virtual something headless without the user, then you use client secrets. OAuth interactive, that's what we want to use. Where we set in authority URL, this is the Azure Active Directory tenant URL, and we're going to use this. So that will be our credentials. Okay, and then we need to get like this these things that we talked about, because these things right here, we get them from Cognite Hub. This is like the main source. If you want to learn anything about Cognite, or you want to ask something, or you want another feature, you want anything to be done here, you just go into here and just create a topic on it. But we're gonna go into the open industrial data here. And here we are gonna see if we can get our OIDC credentials. Also, if you want to generate the client secrets there, you can generate the client secret here for other, and just create client secret, and then you have a client secret that works for 180 days if you want to test it out. But we're going to use interactive login. OIDC, we're going to search for that. Let's see here. OpenID Connect on Open Industrial Data. Check out there. You see here, Shehan has created this article a while ago, and here is details for Cognite client when using Postman, Python SDK, and yeah. So this is the Azure Active Directory client ID. So let's take that in here and add that in Azure Active Directory. I guess it's called tenant ID. And oh yeah, 1N, that's not that dangerous. Then we have the client ID, that's the Azure Active Directory register application ID, Azure Active Directory client ID. Let's just even give it Azure app ID, and the project, that's public data projects, and the CDF cluster, that's API. Yeah, app name is not something we need yet. So now we have stored them. I don't want to take a survey. And then let's go back. Credentials providers, we want this thing right here. Okay, since we are using VS Code, we have a bit more flexibility. So if you just hold in Alt, or Alt, and then you can choose mark multiple lines, and just delete, and now it's nice. So we can edit multiple lines. Okay, the thing that we got from these API, they're not like entirely well set up, because this XYZ here is actually the tenant ID. So this we can turn into an F string and put our Azure Active Directory tenant ID, and we need to make it into an F string. The client ID, we already sort of have that here. We could sort of just post it over. And here you also see, here it says greenfield.cognitedata.com. We're actually gonna put in a CDF cluster here. So it's actually just api.cognitedata.com that we want here. Make it into an F string. Also see that scopes is actually in a list. That might be interesting. And then we again, can go back into the SDK documentation. Let's see here. Yeah, getting started here. You see here, we need to take these credentials. Might even call them creds. And then we need to pipe them into Cognite SDK. So we need to take this line. So we just make it completely like it says in this thing right here. Creds. Oh, what provider it's called here? Just call it creds. And we need a client config and then end up with the client. So client name, I can just call myself Stig. Because I'm Stig. The project that we're gonna work on is project here, so it's public data. Let's just call it public. The base URL here, api.cognitedata.com. That's basically the same thing we had here. HTTPS cognitedata.com. I guess we can set that up here as well. And we need to set it up as an F string. F string like that. Hope this works. And when I run this and run my first query, I would be redirected into this thing right here, and you see that I'm logged in here in Cognite Hub. Let's do a run of this and do client.iam. We can check out the token and we can inspect the token. Now you see authentication complete. You can now close this window. That's nice. And here you see the token. And this is a bit messy, but if we dump it, we turned it actually into, if you check the type of it, just go to the end. It's a dict, it's a Python dictionary. And if we had a simple look on it, we had an overview here of the project subject that might be something similar to like the token. But yeah, projects, it's indexed to projects. So here you see all the projects that we have available to us, and public data is one of the things that we're gonna we have available to our user. But there's also what we specified here that we want to have access to this project right here. I can even clean this up a bit if we're gonna just be a bit fancy. We can turn this into a string temple, a list comprehension. Let's see, for each line with the URL name, because that's what it says here. So let's index that line for each line in this. Now I think we made a list. Now there's a list of projects. So projects available. Probably a misspelling there, but who cares? So now we have a list of this. So now I can just for each project in this, I can print the projects. I get a nice list of all the CDF projects that we have available to us. That's quite nice. That's just yeah, but this doesn't actually matter that much. But now we actually can see what you actually have available to your user. But also now we have client you can see here, if you just dot, we have assets, we have events, files, functions, labels, postput, raw, templates, time series, and all these things that we can have a look into. So if you want assets, we can just list some assets. Then we list up all kinds of assets. So here you have a temperature element, a TE. Might be a bit nicer if I reduce the screen size here, but trying to make things nice here. So TT, that's a temperature transmitter, so temperature measurement device that's connected to a temperature probe. LV, that's a level valve. FT, flow transmitter. Might even have KA. This is actually a compressor. M1 on the compressor. So that's the motor on this compressor. And we can get, these are like overview of the assets, and we can have a look into those as well. So if you go back into our web browser, and we can go into publicdata.fusion.cognite.com, and here you see the same project that we had available to us. If you see here, public data, infield, DE, and all these things. That's quite nice. So let's go into public data here. And here you have the entry field. What do you want to explore data, use data catalog, or explore image data. Here are possibly many things that you can get and do. But yeah, let's explore the data. Here, assets, files, and time series. I can have a look into different files maybe. So let's see here. Let's have a dive into the process, I think. So see where we can start. This is a PDF, shows up quite nicely. So this is the PDF of the suction scrubber, so first stage suction scrubber. So that's like one of the first things that the gas comes to. Because if you see here, here's gas from first stage suction cooler. Before that cooler, it is from the main separators out on the field. And then here comes a recirculation line from the other side of the compressor to ensure that it's not surging. So we're actually gonna have a look into the valve that controls the flow in here. So the valve that's upstream here, we're gonna have a look into, because and here this is the throttle valve, the thing that controls the suction, the pressure inside the suction scrubber and the suction pressure on the compressor. This is a suction scrubber, and this has some plates here, or droplet catchers, and it's set up to collect condensate, because what we try to do with the compressor is we try to compress it and then cool the gas again to get some liquids to condense from the wet gas that we get from the separators. And we want to collect all the hydrocarbon and the water droplets inside a suction scrubber like this, because we have 4 of these stages on this installation. And we collect the condensate here, and we measure it out and put it back into the second stage separator to help. That's where it goes. So back into the oil train, we set this liquid. There's some level measurements and some things right here, and then we have the gas flowing through here and into the first stage compressor. So the next stage. So let's see if we can find some more data. I guess we can. I think it was. I think it's this. Yeah, this is then it's from where we were, from the first stage suction scrubber. It goes into the compressor here, and here you see that there are many pressure and temperature measurements upstream here, and downstream here as well. You even have a flow transmitter here. This is an orifice measurement where you try to measure the pressure difference over an orifice to get the flow measurements, some pressure, some others. And here you have like this hot recycle valve. So here's the dimensions and capacity of the compressor here, and then we get low pressure and a bit cold gas here, But when you compress the gas, it gets a higher pressure and a lot higher temperature when you pressure it out. Some safety valves and to the second stage discharge cooler. So that's 160.001. So yeah, it's 160.001. Let's see if we can find that. Here it is. Here you had where we came from the we got the pressurized and hot gas here. And then it goes into these discharge coolers, and when we cool down this hot pressurized gas, we condense the hydrocarbon liquids, and we want to collect that in a scrubber. So we either push it back into the first stage or recycle it back to the suction side of the compressor, or we collect it in the next stage suction scrubber. These are two heat exchangers that are where we have cooling medium supply here into a flow transmitter, into a temperature control valve, so a control valve. We measure the temperature on the cold cooling medium, push it into the discharge coolers, into the other discharge cooler, and out here. And here we have hot cooling medium. So by looking at the delta T here and the amount of cooling medium we pushed through here, we can actually get how much heat we actually get out of the gas. So we can look into that later. But it's a really interesting case to look into. But also the thing that's been used here as cooling medium, that's a mix of glycol and fresh water. So that's so we know the thermal capacity of this water. So, and when we see the delta T, we can look into the thermals here. So so the 40-60 mix a 40-60 mix of glycol and fresh water. But after it has gone through those, there's a couple of check valves, some isolation valves, some emergency shutdown valves, and then it goes to the second stage suction scrubber. But or this is more important, it goes into this reducer here and this line, and it goes back into into the first stage suction scrubber that we had a look at in the beginning. But it goes through this valve here that's called an anti-surge valve. And this time series here is what the things that we're gonna have a look into, because when we scroll further into this anti-surge valve, we have the flow valve here, and we have the this is a solenoid thing that can if we need to quickly open this valve, because this is quite a big valve. You see here it's a 16-inch valve. With quite the pressure difference over it and stuff like that. And we also have this ZT, that's position feedback. It's not all control valves that have position feedback. Usually we just have the set point for the positioner and not the position feedback, but that makes this valve even more interesting, because we're reading the feedback of the position of this valve, because there's a stem moving up and down. And you have some limit switches for safety purposes as well, because this valve controls the load on the compressor, because the compressor always needs to have flow through it, unless then it starts to surge. If it has too high discharge pressure, the gas can start to migrate back through the compressor. And then we go back into 0152001. I guess can 0152001. That's also that's the first PNID we had a look at, and again we came from this PNID right here from the anti-surge controller. So here goes the loop, and it recirculates again and again and again. So that's like the process, the main parts of the process that we're gonna have a look into. But yeah, let's find was it 165001? It was this ZT 92543 that we're gonna use. So yeah, we found some assets, and we can find a lot of the other things here. So client dot time series, we can list time series, and here we have all the different time series. So it's quite nice. And what we need to actually work with these time series is either this ID or external ID. So when we search for time series, these are the things that we need to get the data points. they say more explicit where we can get these data points. So say we want to have a look into, yeah, what's interesting here. Yeah, this temperature measurement here, I don't know, it's it's a trust bearing. It's not that fun. So if we just search for, say we want to search for we can search for a name, and yeah, search for a PT. That's pressure transmitter, so it's pressure measurement. Let's just suction cool gas out, so out of the suction section scrubber, I think. So it's on the suction side of the compressor. So then we can take this ID. So, and then we go into client time series, and we want data from this time series, and we want to search by ID. Oh no, not data. We want to data, and we want to retrieve data. We can also retrieve a data frame in time zone. We can have a look into this time zoning thing later, but there's yeah, this can be quite useful when you want to specify the time zone, because usually you work with time in UTC, so universal time zone. So yeah, let's just retrieve data, and inside retrieve here we want the ID to be equal to that, and when we search for IDs we just set in the integer, but if we use the external ID, it is a string that we put in here. And yeah, we also see here we actually get some help where we can add a start and an end, and we can we can put in both the date, time. We can put in a lot of things here as well. We can use these strings, so granularity, we can do a lot of things here, and also the documentations also help in here. So start and end, and you can also see start with date times with the time zone equals UTC. So there's many things that you can have a look into and use here. So and also the data that we have available inside public data, it's almost in real time, but it's acting as it is in real time because it's constantly being filled every 5 minutes. But there's a 7-day lag on it, and that's like the only sort of not real-time thing of this thing. And if we set the start to be equal to 4 weeks ago, and end can we just set to now, or I can not use end at all. Then you will see set this to, because then it's automatically thinks end is now. And if I just set end to be now, I guess sort of get the same thing. And yeah, this is then all the data points, sort of in a pandas data frame, but it's actually not entirely in a pandas data frame. So if we press type here and look at the type of this, we see that it's Cognite client data classes, data points. But what's fun with this is if we dir it, if you scroll all the way to the bottom, there's a method called toPandas, and let's use that. Because if I type it, or if I just run it, and I dot to pandas. Oh. Dot to pandas and do that. It still sort of looks like the same thing, but now if I type it out, you see it's a pandas core frame data frame. That's nice. Yeah, the df here, and set that to be our df, and now we can df.plot, and then we plot the data frame. I don't like the name of this. Let's see here. I want to rename the columns, so df columns equals, I can add a list here, just call it pressure, and then plot it, and then you see pressure here. You can even inside here, you can fig size, change the fig size of it, so 12 and 12, so you get a bit bigger figure. But yeah, then you can actually plot it and look at it. That's quite nice. but yeah, that's our sort of DF. But we were supposed to look into this valve mileage case, or valve case. So we saw that it was a ZT. Let's just search for the ZTs. Oh, it's only 2 CTs here. And it was 92543, that was the anti-surge valves ZT. The other one's CT is actually this suction throttle valve that we also looked into. But let's focus on this anti-surge valve, because that's more prone to have issues with the big valve that's supposed to move quite fast. Here's the ID of it. Let's just look at the ID. This isn't pressure, but yeah, now it's called it pressure. Let's just do the query again. Have a look at the DF, and now it's already in in a pandas data frame. But we can rename it to, because this is the percent opening. So call it percent opening. So, and now if we look at the DF, it's now percent opening. So let's just clean up. And what we're gonna do with this data, we're gonna figure out how long or how much this has moved in total. And that's like the thing, and we're gonna have a look of that and use that and do that through Python here. So, and see if we can scale it out and stuff like that. So from position opening, we want to, because this is in percent, how many? Oh, that's around 30% open. What we want to first turn it over to is to turn it over to an actual length. So if we know the travel length of this valve, say it is valve travel length, set that equal to 32 centimeters, say it's 32 centimeters, and we want this to be sort of normalized to that. So we want to take the valve opening, divide that by 100. So now it goes from 0 to 1, where 0 is fully closed and 1 is fully open. So now it would be, if this is the point that it is right now, then it would be 0.29 would be the position. And then we take that and we multiply that times the valve travel length. So and now you see that we get it in centimeters. So that's nice. It's always nice to get over to units. And we can call since we received this in a series, we can call that series valve or position percent opening. Now it's opening in cm, so opening in centimeters. And now look at the DF. I have two lines here. So yeah, And since we're gonna look into how much it is actually moving, we want to see from each point, it moves a bit. So from here, it moves to here by a certain amount. So let's do the thing that we have done previously in previous videos. We take this centimeter opening and do the diff on it. You see now the first thing is none because the difference between the top and this one is sort of quite low. Or there's no data point before this, so it's none, it's not a number. And then we have all these different movements. So so we can call this, since this is a series, because whenever we do anything on it, we receive back a series. Let's call this position change, because it changes for everything. Also, you see here, there's not the uniform delta t between here as well. So not the uniform, it's not constantly like every second pushing data in. So we might in some cases take that into account as well. But we're not gonna go that deep into the mechanistics here, but almost. So let's just call that the position change, and let's have a look at our DF then. Now you see that we have top here is a none. It's quite easy to get rid of, but we can just get rid of it. You can either interpolate it and like limit directions both. That's a way to it. So df dot interpolate and limit directions to both. Then you see here we just get the same value, or but it's not stored to the df, because if I see it now, it's not stored. You can also just slice the df, just skip over, give me anything from index 1, not index 0, and to back. And then you see also we sort of cut off this first df. I guess we can just do that. A simple way of doing it, just skipping the first index. And now we're making a slice of the data frame to the main data frame. But yeah, so now if we look at the df, now you see that it's all good. So let's just have a look at this this position change. I can plot it, I guess. So here you see the position change. It either moves a bit more open, or it closes a bit more. Moves a bit open or closes, or something else. So it moves all around 0. But we want to figure out how much it's actually moving in total. So if we just accumulate all the change here, then it would sort of approach 0, because it's plus something and minus the same amount, so constantly moving around. We can actually have a look into that, because if we just take this and take the value, and give us the series and values, and then we get the an NumPy array of this. So we can just and if we just loop through and just sum all the differences, I think it would sum to almost 0, because of the directions are cancelling out. So let's just say for each value in, let's just loop over this entire thing. Oh, we need to get a counter. Let's call it a sum, and each light is at 0. So the sum plus equals. So now it just value. So now it's just for each single value here, it just adds that value, and this value is usually a bit positive or a bit negative. Let's just have a look into the sum and check out. Oh no, not sir. Sum. Yeah, it's just around. Oh, it has moved this much. It's not much at all. So now we only have like the position change from the first position to where it ended up. So yeah, but we want to count how much it has moved in total, because this is in centimeters, so it's not really that far. But we can think about if a valve is constantly moving, how much it's moving at all. But what we simply can just do then is we can take the absolute value of the position changes. So let's just use npi, since we have numpy already added here, np dot abs, so absolute. I guess we can also use absolute and just put in the values there. And now everything's now we have sort of killed the direction and actually turned the position change, or sort of the velocity to a speed. We can't really say that correctly, because we need to take the time between each data point into consideration. We're gonna have these actually as velocities and speeds, but actually, yeah, to turn this speed into this velocity into a speed, because speed is the absolute value of velocity, but that's physics. And if we just count up all of that, I guess we get a lot more. And now we actually get this many centimeters. If we divide it by 100, then we get it in meters. So the last, say, 4 weeks, or actually it's 3 weeks, because it's from 4 weeks to 1 week ago, it has moved 276 meters. So it's quite an active little valve, or it's not a little valve, it's quite a big valve, but yeah, this is quite insightful. But let's put this thing right here into a DF and call that DF. Let's call it absolute value of position change. Oh, now I get a warning because a value is being trying to set into copy of a sliced data frame, because yeah, I sliced it here and set that value to the DF. So yeah, now it's a bit afraid because I'm doing these operations on a subset of the initial data frame. But yeah, that doesn't matter in this case, because I just moved the first index. So yeah, maybe not the best practice, but hey, what do you know? This is exploratory code and an exploratory notebook. So yeah. Now we have the DF here, absolute value of position change, and since we want to make this into a new row here, we can take this value here and do a cumulative sum, so we get a series in return. So it just takes this and adds in this, and then adds this, and then adds this, and cumulatively sums up along this this line. So this becomes this plus this plus this, and this becomes everything plus this plus this plus this plus this plus this plus this. So yeah, so this is the cumulative sum, so the cum sum method. Yeah, they could have named it something else, but that's what the developers chose to call this function, the cum sum. And now we have a series where we accumulate how much it has changed, and let's just call that that DF here. Let's call it traveled in total. I also get the same warning here because it's we're working on a sliced data frame, but yeah, that's just my stupidity. And now if we have a look at the DF here, we have this thing right here, and we can plot it. Plot. I actually think this is quite interesting, because around this we had a shutdown. Let's just go a few weeks back, even further. Let's just go to 6 weeks ago, and then we do all these calculations again, and then we have a look, and you see quite clearly a change here, because this was an ESD test that's set by the operators of the pipeline. Every year we need to do a check of the emergency shutdown systems. And during this 1 day ESD test, we also did some maintenance on these valves, on the positioners and stuff like that, and you actually see a difference in dynamics. So actually now it moves a lot more, or it has slowed a bit down here, but it still moves a lot more than previously. I don't know if it's healthy or whatever, but this is I think that this is quite insightful, because usually you don't want these valves you want them to move, but not to move too little and not to move too much. Because if we have a look into how control valves are, maybe we can search for the search valve. Yeah, I guess this is sort of an anti-surge valve, where you have this pneumatic piston here. Or I can even better. Yeah, this is quite nice. These are quite big, but this is a pneumatic piston that operates a seat or some other valve inside here, some other valve type inside here. And whenever this moves up and down, it can sort of wear and tear on the packing material between this valve top. Actually, the top is called the bonnet. But yeah, that's the valve top here, and if it moves too much, it might rub off, and then we can actually get the process media leaking through the valve stem. And the valve stem is the thing that's connecting the actuator. This is a pneumatic actuator, or this is a piston inside here, where you push air in above and below to control the piston. That again is connected to a rod that's called this valve stem, that again controls the position of the valve inside here. And if this moves too much, then we can get process medium that flows through here. Or if it's calm, if it doesn't move a lot over many periods and suddenly do a movement, then it might have some more friction towards the packing material and rip more of the frictions. So operating these things like optimally and getting an insight into how they behave can be sort of valuable. And that's exactly what we've done here. And we see that we are operating them sort of differently. I don't know what is most healthy and what is not most healthy, but still it's quite interesting to look into these things. But yeah, but now we've done this for one time series. Maybe we can compare day by day and not just in total, and see if that makes more sense. So we can maybe combine this entire thing right here into a function or something that spits out a data frame. So let's just call it df or def. Let's make a function called valve valve behavior, and we want to take in the ID, And what else is we want to specify the time segment. So start and end. What have we done? So this is the time series ID, the resource type ID. What have we done? We have first we took this SDK and we got the data frame from the ID. Let's just change out the ID, and also from start to end. So, and now we have the data frame that we can work with. And let's just do the same thing that we did here. We rename the first series inside the data frame, and then we calculate the valve travel length. But let's just normalize the data to between 0 and 1, and just maintain that. Look away from the centimeters there, but let's just normalize. Position change, I get the position change, and after that we sliced out the first row. Then we took the absolute value. Then we took the absolute value of the position change. Absolute value of the position change. Yeah. And then we can, I guess we can df of this this thing right here, and let's just plot it. So we can, and then we want the ID that we used. We want this ID. Or we can just take this entire thing right here. So put in the ID. Start equals say we just want from 2-3 weeks ago to now. Let's just comment this out, see what we get. I is not defined. Oh yeah, like that. And now you see, oh no, we didn't sum up, huh? Yeah, this was the thing we needed. That was the last thing we did to it. Yeah, this is this wasn't that interesting. Let's have a look at 4 weeks till 3 weeks ago. Huh? We are straight at the point where this ESD stop happened. But yeah, we can do this actually programmatically. Say we want the so date time, we can add the date time, and we want 2023 6 from the 4th. Start it there, and we want to end at say the 6th. So now we have this is the ESD stop, and then it started ramp up, and then we start production again. But say we want even say from the 1st to the 7th. Now it's getting quite flexible, this, and we can do anything, everything just purely programmatically. Maybe we can even be a bit more interesting about overlaying how days operate by each other, because how do we do that? Because if we look at the DF, let's try say we want for say we want the time range of 7 days in range 7 days, and we just want this to be done, and then we can add time deltas here. So just go up here and also import time delta, and so I want it to start, and this is where it's supposed to start and where it's supposed to end. So maybe more. We need a start date, but how do we get the start date? So we need to get say datetime now. Let's just call that dtn equals this, and then date, because this datetime now, that if we check it out here, this if we check the year here, we get this, month, we get that, and day, get that. So we can set start to be date time of datetime the year, and datetime that this is the month, and then we have the day, yeah, and then we can just count time deltas on top of this. So we want it from start minus time delta, and we want that to be in days. We also know that we don't get data before the 7th, so we want 7 days, 7 days back. To end it on that, so I want to start it the day before, so 7 plus 1 here, or not 7, I plus so 7 plus 1, that's start minus 8 days, and it ends at start minus 7 days. So this goes from 8 days to 7 days. And then the next, when this becomes 8, so this becomes 9 to 8. Yeah, let's see what we get. Interesting. But we maybe want to overlay these on top of each other. Maybe get even more. These are interesting. But yeah, let's first try to kill this index and make them just on top of each other. So instead of plotting them, we return just return the values. So, and then instead of just plotting them, we return the values. So this returns a numpy array suddenly. So if we just do this, suddenly we just get an array of these data, and then we need to did we include matplotlib.pyplot? No. Import import matplotlib.pyplot as PLT, and we want this plt.plot, and we want to plot the return values that we get from this. Let's plot them. And then plt show after you've done with the for loop. Yeah. You clearly see that there are two domains here, but let's try to separate this out a bit more. You can do plt figure dot figure, and let's add the fig size in here. Fig size 1313 maybe. Get a bigger figure. Oh, this was quite big. 8 by 8. Because yeah, the UI scaling here is a bit higher since I'm making this video. But yeah, 10 by 10. Yeah, you clearly see either it's here or it's operating here. And I guess that's like the slope before and after the ESD stop. So and also it's not every day that it fills up, but we have the time dimension here. We can go from 0 to 24 hours. Because if we have a look at the DF, we can check out the index. That's date time 64 in nanoseconds. And the way that this date time 64 in nanoseconds is set up, it's just the number of nanoseconds since the Unix epoch time. And Unix epoch time that starts the 1st of January 1970. So it's just the number of nanoseconds since that day. And we can actually view this since this is a Panda series, and Pandas is built upon NumPy. So if you view that as a NumPy int, but the 64-bit int, since this is date time 64 here. So int 64. Oh. Then we actually have the number of nanoseconds since the 1st of January 1970. And if we just deduct this value, the first value, we just get the number of nanoseconds since this first value. And we can just get the first value by indexing the first value. And we then take all the indexes and deduct this value. And then you see here, so it's 0, then this many nanoseconds, then this many nanoseconds. And we can set that again as the DF's index. Let's just do that and see what we get then. So df.index equals this. But then we don't want the values to return. We want to return the series with this index. And then they all have like the same index. I think that might work. And let's try to run this thing now. Yeah, now you see here. Now it goes from 0 to 9 times 10 to the power 13. It doesn't really make that sense, but now you see that we have one common index. But we can turn this even into I don't know, a number of nanoseconds during a day. Oh, let's take this and divide it. How many nanoseconds is there in a second? So nano, that's 10 to the power of 9. 1 E9. Then we're in seconds, and there's 60 seconds in a minute, and there's 60 seconds, 60 minutes in an hour. I think that should be better. And then we can show it. Oh, what happened there? Oh yeah, I need to first encapsulate this, and see now. Oh, let's run this now. Exploratory code, so it's a bit glitchy sometimes. Yeah. 0 to 24 hours. This makes sense. It's quite nice. And yeah, we still see this region here, and we see this region here. So it's quite clear that we can actually use this and classify this into different behaviors. So, and that can be useful with industrial data, because later we want to classify things, we want to create machine learning classifications on this, so we can be automatically alerted if things behave differently, or if it's healthy, or we can have a machine to interpret this for us. But it's new dimensions into how things actually behave in the industrial space, because previously we things like this had either been very specific to operate inside like a closed SCADA system or something like that, but now we can actually do these types of analytics on historical data, and previously like all this data has not necessarily been available to anyone. But yeah, maybe we should even try to isolate it, because we saw that it was around the 5th. So say if we can color equals red initially, or if if this date is greater than or equal to date time 2013, 6th, and was it the 1st or the 5th, or what then was it? 5th, or say the 4th. Then we can set the color to be blue, and then we color equals color. So now either the default color is red, but if it is after this fifth date, or the 4th, then the color is supposed to be blue, and we can have a look at them, see if we can actually separate out that behavior. So now, yeah, here you see the ramp up days, and then you see all the days before the the ESD and after the ESD. We can even let's label the data. Let's label them as let's build a string equals dot oh, I need to, since this is daytime, we want the month, and just concatenate a couple of strings. Yeah. Then we want the day, and then this. So this iterations labels equals this iterations labels, and then we also need to add plt legend string. Oh yeah, I need to turn that to a string. Also need a new like that str, like so. So here you have the dates, and then it's quite clear that this was the day of the shutdown. But yeah, I don't completely like that, but it's behaving differently now. And if we say, are these like how it is now? Maybe it's changed. So let's say 10 to 31 days. Now it's even clearer. So it is sort of calming down this valve. I don't know the reason, but interesting. As now I should be at work and talking to people, but instead of spending days just creating videos. but yeah, this is interesting. But now we've actually done something cool and specific. Maybe we can even turn this again, since everything is programmatic here. Let's do this for the other valve as well, and then we can just take this entire thing. So call it the Valve Diagnostic. Oh yeah, that's even what we call the project here. So Valve Diagnostic, and we put in an ID, and then we just do this. Oh, I just need to do it like that, and execute it, and then we can go up and get the other ID as well from the other ZD. So this ID, and just give in that ID. Strange. Oh yeah, because this was the same. I need to set the ID here into this. I guess it's becoming quite late. And this is there's also seems to be two regions here as well, but it is behaving more normally, but you still see clear difference there as well. But that sort of makes sense, because the anti-surge valve and the suction throttle valve is actually in series somehow, and they both try to sort of control the same thing. Yeah, interesting. Let's go even like deeper, since now we can do it by just adding the ID. Say that we had maybe 150 anti-surge valves in an entire like oil and gas company or something like that, big EMP company, and want to do the same analysis on everything. We should be able to do that as well, because we still have this client, and we had the time series, and search for time series. We didn't have that many ZTs, so position feedbacks, but shall we just do it for all? Say that all the pressure measurements are actually valves, but they're time series, and since we build everything up on top of these resource types, I think that is quite powerful. But you see this response here. It looks like a Python a pandas data frame. But again, if you just go into type it out, and look what it is. It is a time series list. And the fun thing about lists in Python, Say we want index number 6. There is index number 6. And here we have the ID, external ID, the name, yeah, the unit. If I go dot again, the asset ID, the description, the ID, dot ID. You see where I'm going? So let's for each valve in my list. So the valve has a, we can maybe, let's print the valve name, concatenate that. So we stringify the valve name. I think it's already a string, but yeah. And we can, let's just add a pipe character. And then valve.description. I don't need this because they're all strings. And then we do the Valve Diagnostics on valve.id. Let's just first check it out with the ZTs, the two. Now we do it to the suction throttle valve, and then it is on this anti-surge valve. But say we just do that on all PTs. So first it does it on the first stage suction cool gas out. So this is the suction, the suction scrubber on the outlet of the gas. You actually see clear differences in the movement of pressure. This is the suction, this is the input, the pressure input on the suction side. This is the pressure change within the suction scrubber. So is this. But now it just goes through, and say you want to do even more advanced things, more advanced than just these things that we've done here. This is the beginning of superpowers, if you ask me, because it's so magical what we can do and get when we do these things. So I think it's quite magical. So yeah. And just continuously do more. First stage, outer seal, drive end. This is the change in pressure on the drive end of the compressor, on the non-drive end of the compressor. So it's quite amazing. This is on the first stage oil header. So I guess it's the lube oil on the compressor. I guess now it's done. Quite nice. Say I want to do it on all the temperature transmitters, all the TTs. Just go ahead, and now it just runs through all the all the temperature transmitters. So I really think that this is a very useful tool for doing anything. But right now, this is like, the scalability aspect of it. But also, if you have a fixed set of a system that you're taking care of, that you want more insight into, that you some things that you want to look into more and more times, then index out of bounds. I guess it went through everything and oh yeah, and ended up with time series that doesn't, or the time series maybe have stopped or something. But yeah, finding these edge cases and correcting them, it's all part of the game. This is how the temperature is actually behaving. And here you see temperature is moving also more. I think this is very interesting. And all a notebook that we have built here, all packaged inside a nice little closed environment that we have here. And yeah, this is a start. One thing we can also do, just for simplicity case, is to package this up a bit nicer. Let's just go up here and create a new cdf.py. Call it a new file. Just yeah, set it here. Then we can take these things right here, add them here. Just create the file, call it cdf.py or something, and just keep this in a local module outside of our notebooks, so that we don't necessarily cloud things up. This is usually how I do it. I just have this in a .py file in the directory, and just import this. So instead of having this at the start of all my notebooks, so if I create another notebook, say yeah, a new nb new notebook.i python notebook, and now since I created this CDF here, I need to save this. Doesn't like it anyhow, but I can just from CDF import client. So now I just CDF, that's the local cdf.py here I had here, or call it publicdata.py, or call it whatever you want. And from this module I import client. So now, because client is instantiated here, and when I run this, oh yeah, I need to select the kernel here, select the venv, and now when I run it, I get the client, and when I get the client, and I do want to time series, I want to list time series. Now it goes out, authenticates me, and it lists time series. Maybe we should even clean this up again. Let's just call make a file called valve sticks.py. Might be able to do like the same thing, and we can just collect everything we did. All these, we made this, and then we made this way of Valve Diagnostics here. We need to import our libraries. Oh, we actually didn't use pandas. If we had used some automatic linting, usually that removes things that we don't use. So, and also so we also need to import the Cognite client here. Because it doesn't know it here, let's just add the client here. Yeah. Client there, and we need need to add the client here, and then here. Might be better ways of doing it, but yeah. So now all we need to add is the ID and the Cognite client. Valve Diagnostics. And now we've created a Python file called Valve Diagnostics inside here. So now client.timeseries we can search. We can search for a name equals DT again. Yeah. Then we have our time series that we're used to work with. Close this. Save it. Save this. We have this Valve Diagnostics. And say just want the from Valve Diagnostics import Valve Diagnostic. I found it even for me. Now we're creating local modules. So yeah, I want to do that on, oh yeah, maybe even go a bit more deeper, because I even want this. Yeah. But yeah, now I have Valve Diagnostics here, and I also needed to add the ID, say this ID, and I need to add the client. I've imported the client here. Valve Diagnostic. And now here we did the same thing that we did, but now we just imported things. And say we want to just loop through everything and do our jam again. Let's close that notebook. Let's close this. Close this. We're here in my new notebook. And for each valve inside this thing right here, I just need to add the client here. And yeah, we want to do that for all the pressure transmitters. So now we're packing things up and making things reusable and setting things up to be nicer. There's possibly better ways of doing this, but I think this is quite nice and quite clean. I often like create web applications that push this type of data out that I use in my day-to-day, have a look at. But that we can look into on a later video. But right now, one of the things that we often need to do is we need to enable more people to be able to use this. So let's jump into GitHub. And now we're in GitHub. Let's, okay, I can just go to my profile. And here we can create a new repository. We can call it, yeah, I need to select me, Valve Diagnostic. Yeah, doing Valve Diagnostics on public data CDF projects. It's going to be public. Yeah, licenses, a thing we can fix later. I create the repository. And now we can take, yeah, it's still working and still pushing out these things. It's quite fun, this. Now we can put this into a GitHub repository. So we need to do git init. Let's just zoom in here. So git init, initialize git. Now we have git up and running here. let's add git ignore file. Oh, .git ignore file. Let's just use Python git ignore. Yeah, been here before. This is typical what I do. Just go raw this, and because this is GitHub's recommended like git ignore collections before we do a commit, just copy all this, put that into our git ignore here, save that, and now you see pycache and venv becomes grayed out so that they don't become a part of this. Yeah, we have a readme here. I guess we can preview the readme up here, and then we can create the readme here. So let's have heading 1, Valve Diagnostic case with CDF data. Now you see I have a main thing here. You can also add, you can learn how to use this MD. This is markdown files. This is really essential to use. It's a really nice way of documenting things. Where, yeah, stomach is making noises. So yeah, here we can add anything. So say we want to add like code or stuff like that. We want it to be, say, bash maybe. So we need pip install poetry. So then poetry config virtual env.in project to true, and then poetry install, because then that's what we need to like get this thing up and running. Or yeah, set up git set up the bit in a Python environment. That's nice. And then and what more did we? We selected the Python interpreter. And Python output kernel, but that's also being installed here when you go poetry install. And then I think that was it. Then we can also add some Python code. What more is it that we need? We had the new thing right there. So we had this, and then we just do Valve Diagnostic and yeah, and then we are up and running. We can even make this into a module and stuff like that and publish it to PyPI called maybe Valve Diagnostic. So then you can pip install this wherever you want, and you can do this Valve Diagnostic case from PyPI. I can show that in a later video. But yeah, and now we have created a README file with some information that's nice to have. Book and exec this. So yeah, this is all nice. Then it's back to, we've initted the git, and then we need to git add, but we're not adding readme.md, we're adding everything. Git add and everything. It's just a dot. And now we've staged everything. And then we just add the first commit, and we set the branch to be master because that's the default main branch at me. And then we set the git remote add origin to be in this thing, and that's when we set the GitHub repo to be the remote origin. So and now we push all the data into remote origin master, so the master branch on GitHub. And now when I do a reload here, well, what do you know? We're up and running, and you see here this thing, this is bash, and this is highlighted with Python code. It's really nice and really good. I'm also gonna add a link to the YouTube video series here and all that. So I think this will be quite nice. I think this can be useful, and also make a few more videos where you can take this case and maybe do something else and enable more people to use it and look at it and stuff like that. Maybe turn it into a web app or something like that. Maybe set up some tests and do some proper DevOpsy things here, because it's quite important to get things into GitHub and get things in under code revision, because then you can actually maintain this and make it better, make it more specific, and get this more up and running. But I hope this wasn't that's scary, but it's a really nice way of starting to use this thing. So yeah.